Power management ICs generally have an N pin used to enable the output voltage. When the voltage on the N pin is below its threshold, the power IC has no output. When the voltage on the N pin is above its threshold, the power IC operates normally. Next, let's discuss several connection methods for the N pin of power ICs. The first method is leaving the N pin floating. In general, the N pin of a power IC should not be left floating. However, some power ICs have an internal current source on the N pin. When the N pin is floating, the internal current source turns on the power IC. The second method is connecting the N pin directly to the input supply or pulling it up to the input through a resistor. This method is commonly used in LDOs. This is because the LDO input voltage and the N pin maximum voltage are usually at the same level. For DC-DC converters, it is necessary to consider whether the input voltage exceeds the N pin maximum rating. When the N pin is tied to the input pin, the output voltage is easily affected by the input voltage during power-up. The third method is connecting the N pin to a resistor divider network. This method effectively prevents output voltage from being affected by input voltage fluctuations. The output can be enabled when the input voltage rises to 70-80. At this point, the output voltage is more stable. A resistor divider can also be used to set undervoltage lockout, that is, the output is disabled when the input voltage falls below a set level. At the same time, the resistor divider allows the output to shut down earlier when the input power is turned off. The fourth method is using the CPU's GPIO to control the N pin. Enabling software control of the power on and off. This enables power management. If there are multiple power rails, software can control their power-up sequence. The fifth method is connecting an RC circuit to the N pin to control power-up timing. By using different RC values, the time for the N pin to reach its threshold can be adjusted. This creates a defined power-up sequence. The sixth method is connecting the N pin to the power good signal of another power IC. This enables cascaded power control. Because the power good signal goes high only when the output reaches 90% of its rated value. Before that, it remains low. Therefore, Vout to outputs only after Vout1 has powered up. This achieves proper power sequencing. That concludes today's sharing. Thank you all.